according to AS 1562 and MS 2005, brought to you by NS BlueScope License. We appreciate very much if you can mute your mic during the session, and you can raise your question from time to time by typing into the chat box with your email address. I will try my best to answer your question in the end of this webinar. Otherwise, I will return an email to you to answer your questions. All right. First, let me introduce myself. My name is Chia Hao. You can call me Jia Hao. Currently, I'm the Technical Solution Manager of NS BlueScope Malaysia. My scope of work include technical services, product development, digitalization, and business support. I joined NS BlueScope in 2015 as a product development engineer. Then I changed my role as a business development manager in NS BlueScope License Singapore in 2020. I spent more than 15 years in the construction industry since I graduated from University of Malaya in Malaysia with the bachelor degree in civil engineering. I also obtained my master degree in management of technology from NUS in Singapore in the year of 2010. Along my career, I am involved in civil and structural design, project management, testing, and product development. Right, this is a short brief about myself. Okay, today's session we'll be focusing on the comparison of the similar topic appears in AS 1562 and MS 2005. In addition, those standalone requirements that stated in each standard will be shared also. The sharing information shall be the basic guideline to the audience in terms of how to select the right product and how to use it correctly. As such, today I'm going to share with you in 6 topics, which includes the introduction of AS 1562 and MS 2005. Then I will do some comparison in between 2 topics, 2 standards in terms of material and testing. Upon that, I will share some standalone requirement in each standard, which is the design in AS 1562, installation in AS 1562, and specification in MS 2005. Then in the end of the session, we'll open a Q&A session to all the audience. Okay, let's get into the first topic of today, the introduction of AS 1562 and MS 2005. Okay, normally, when think about metal sheet, public will have the impression that it is used for the compound houses, for the warung, pedestrian walkway, etc. It is so common to be seen and so common to be used. As such, most of the people, even the industrial players, do not consider metal roof as a specialized product. The impression of the metal sheet is it's just a commodity product, and so there's no difference in between suppliers. Any material is the same because it's just a sari. The sari is a common so-called the name used by the industrial players saying that it's a cover of the building. As long as this can get the sunshine shaded and cover the building from the rainwater, then that's it. This is for the metal sheet. Then most of the people also think that metal sheet can be installed in any method. As long as you create it enough, you just buy the metal sheet and just throw it to the workers, then you do it the freestyle. In addition, most of the industrial players may be not aware that there's an international standard can be used as a guideline to choose for the right product of the metal cladding and install it according to the standard. All right, so come to here, for those who always have the mindset about the metal cladding that I mentioned just now, maybe now you start to flip your project tender document and check on the specification and then ask yourself that, oh my God, am I using the right metal cladding in the project? So I hope the following sharing session can change your impression about metal cladding, and I also hope that with the information I share with you is able to assist you to choose for the right product in your project. Okay, in fact, in the market, there's not only one international standard to guide us to choose for the right products of metal cladding and guide us to install it correctly. But there are few codes that play the role to assist us in choosing the good product of metal roof and wall cladding, such as the Australia Standard 1562, Malaysia Standard 2005, and Singapore Standard 631. These are the good guidelines for the designer when metal cladding is used in the project. In today's session, we'll be focusing on the AS 1562 and MS 2005 only. We shall arrange another session to talk about SS 631 if the response from the audience of this topic is welcome. All right, so what is AS 1562 and MS 2005? AS1562 is the Austrian standard, mainly focused on the design and installation of metal sheet roof and wall cladding. This standard specifies detail of the metal sheet requirement in terms of the material, design, installation, and testing. Whereas MS 2005 is the Malaysian standard of the roofing products from metal sheet and is focusing on specification. So the standard is mainly mentioned about the requirement of material, testing, and specification. So as you can see in this table, I already put up the so-called similar topic of two standard and some standalone topic in each standard. So the similar content in between both standard are the material and testing. Let me point it out. It's easier. Hold on. Material and testing. Okay. So I will do some comparison to show the similarity of the differences of this standard. Whereas for other content that are standalone in each standard will be discussed in the matter of how reader can use the standard to cover the content that is not included in other standard, such as the design and installation is only appear in AS1562, and the specification is only appear in MS 2005. All right, let's get into the topic of material in the comparison of AS1562 and MS 2005. Okay, before we get into the detail, let us understand the terminology that is commonly used in the industry when we talk about the hot dip galvanized cold roll metal. If you take the specimen from pre-painted coil and put it under the microscope, the structure of the specimen is illustrated in the graphic as shown in the middle here. So this is the graphic of the so-called the structure of the component when we put in the microscope view. Before we do any treatment to the bare metal, we call it as a cold roll coil. This cold roll coil, or in short form, we call it CRC. Okay, this is the base metal to form the shape of roofing and walling product. The bare metal can be in aluminium, copper, stainless steel, etc. Since NS Blue Scope core is selling the steel, so we name the base metal as base steel. So this is a base steel, right? When the CRC has been processed with the metallic coating in the front and back surface of the base steel with the hot dip galvanized method, we name it as metallic coated steel, or we call it as Singulum as a product name for NS Blue Scope. The front and back of the metallic coating steel or Singulum is just the bare silver color without any color coated. So this is how it looks like when in the metallic coated steel process. Upon the base steel is metallic coated, the Singulum or the metallic coated steel will go through the painted process. This is a continuous painting line in the factory to form it with the designated colors. When Singulum is painted with the colors, we name it as pre-painted metallic coated steel, or we call it as color bond steel as a product name for NS Blue Scope. So in short, there are three stages in the process, which are the base steel stage, cold roll coil stage. Then second stage is a hot dip galvanized stage. The end product is called metallic coated steel, which will come to here. Then the last process is the pre-painted metallic coated steel process. We're putting the color at the top and bottom of the steel. All right, let's see what content is covered in the both standard when talk about the material. Okay, in AS1562, it is more focused on the base metal and the fastener should be used. In addition, it directs the reader refer to AS1397 if they would like to understand the metallic coating requirement. Okay, however, in MS 2005, it is more focused on the metallic coating requirement for steel base only. In other words, in AS1562, it's not only talking about steel. It's talking about the requirement of metallic coating on the stainless steel, aluminium, copper, other metal. But MS 2005 is more focused on the steel. All right, so and similar to AS1562, MS 2005 also direct reader to understand the metallic coating requirement according to the different standard, which are the MS 2660 MS2657, and MS1196. So I will cover the important requirement from each standard that is related to steel so that it can help you to choose the right specification when you use steel cladding in your project. All right, this table is a summary of the requirement of the material and fastener when different base metal is used, and it is extract out from the AS1562. As I mentioned earlier, we will just focus on the steel as a base metal along the sharing session so that we will not get into the detail of other metal material in this table. Okay, as highlighted in the red box here, we use the steel as a base metal, and the material must comply to 1397, the continuous hot dip metallic coated steel sheet and strip coatings of the zinc and zinc alloy with aluminum and magnesium. This is the topic of the AS1397. Okay, as you can see here, we have 3 types of the metallic coatings specified in this table. For the base steel according to the 1397, which is either in zinc, which is as shown in SAG, or zinc with alloy with aluminum, which is SAG, or the zinc alloy with aluminum and magnesium, this is AM, right? So there's a reason you only can see 3 types of the aluminum minimum coating requirement is stated in this column 3, which is the SAG 450. It means that zinc with the minimum coating mass of the 450 gram per meter square, and SAG 150 means the zinc alloy with aluminum, and the minimum coated mass is 150 gram per meter square. And the last one is AM 125, means that zinc alloy with aluminum and magnesium, the minimum coating mass is 125 gram per meter square. All right, this is the so-called the minimum coating that is stated in 1562 that direct you to 1397. All right, this will be the guideline for you to ensure that you are using the minimum coating product in your project. For example, if a supplier approach you and offering the SAG 400 or SAG 100 or AM 100 to you, this product may not comply to the bare minimum requirement according to AS1562. And you maybe need to reconsider, shall you use this product in your project if you adopt 1562 in your project, right? Then regarding fastener, the last column here, all right? There's no matter, it's stated that no matter is screw, nail, or bolt is used in with the steel cladding, it must comply to the AS3566.1, which is with the topic of the self-drilling screw for building construction industry, part 1, general requirement. This is another guideline for you to ensure that the project is use a suitable screw for the installation, but ensure that the supplier must submit to you with a specification that show that AS3566 is compliant. Let's get into the MS 2005 and see what's the difference in the material requirement when compared to 1562. This table 3 is extract out from the MS 2005 clause 3, nominal metallic coating. It stated 2 requirements based on the different metallic coating condition, which are with organic coating and without organic coating. So what does it mean is, according to MS 2005, product obtained by factory application or paint by roller or spray process is considered as organic coated steel. In other words, organic coated steel is produced in the coil coating process where material is applied on the raw metal strip in a continuous process that include cleaning. So NS BlueScope steel is produced in continuous process, so it is considered with the organic coating. As such that we will just focus on the minimum metallic coating in the column of with organic coating. All right. So refer to the table. The tolerance of the nominal metallic coating requirement in MS 2005 is much bigger if compared to AS1562. Because as you can see here, as highlighted, the coated mass of the 90 gram per meter square for AM and SAG is acceptable, And then 80 gram per meter square for zinc coating is tolerable too. So when come to hear that you maybe have confused that there are two standards with a very difference in the material requirement appeared concurrently in the market. So you might confuse that which one should be referred, because one talking about minimum seg should be 450. MS talking about seg 80 can meet the minimum requirement. So we have some suggestion here. So if you do not have any preferences using which standard in your project, you are suggested to refer to AS1562, which is the more stringent standard. Although you have a lesser choice for the thinner coating mass product, but you are confident that you are using the higher quality product in your project. However, if you prefer to use MS, it's okay. You will be having more choices in terms of the metallic coating, and you might get a cheaper price of the product also. But you maybe need to consider, is the material performance match with your building design life? So you should pay more attention to assess the supplier warranty. Okay. Regarding the steel grade requirement, AS1562 does not specify the minimum and maximum steel grade for the roll forming and press brake. But MS 2005 is specified the basic compliance that need to be met. This table 1, as shown in this slide, is straight out from the MS 2005, clause 4.2.1, materials for roll form and press brake profiles. As shown in this table, the types of the metallic coating are specified, which are the zinc alloy with aluminium, and zinc alloy with aluminium and magnesium. So there's three types. It's quite similar to the AS1562. And if you read this table thoroughly in detail, you will find that the steel grade present that in each metallic coating is the same. As you can see, even in zinc aluminium, magnesium is 250, 250, 250. So which means that in that case, we can summarize that no matter what metallic coating is used, the steel grade that can use to do roll form and press brake according to MS 2005, minimum is 250 MPa and the maximum is 550 MPa. So what does it mean to help you to assess the product is, if any supplier offer the roofing and walling product to you, there is roll form or press brake with a steel grade lower than 250 or greater than 550, and then commit that the performance is guaranteed, then you maybe need to get more proof from the supplier to show the competency, because as specified in the code, is not allowed to have lower than 250 and higher than 550. Okay, let's get into the third topic. It's talking about the testing comparison in between AS1562 and MS 2005. Okay, this is the comparison. Okay, regarding this section talking about testing, both standard showing a lot of similarity, although there's some minor differences is found. For example, like MS1562, that specified the testing specimen is more on the fabrication on the profile and the full assemblies that maybe affect the mechanical performance during the testing. But MS 2005, they are more focusing on the material. So what does it mean is MS1562, they are more focused on how you fabricate the profile and how the assembly method will affect the testing result. But MS 2005 is more focused on the material that before you roll form the profile. All right, so this is a difference between both standard. And also in AS1562, they specified how to derive the design value by using the different reduction factor based on the number of tests. But MS 2005 does not specify it. So let me elaborate more is AS1562, it gives you the reduction factor of the value that you harvest from the testing. But MS 2005 does not really specify that. Okay, then now come to the, we take a look at the similarity. The common ground of the both standard is they request the manufacturer to prove the steel cladding performance in concentrated load and wind pressure. AS1562, they only accept the testing according to AS 4040 to prove the performance of the product. But MS 2005, they allow the manufacturer to choose either use calculation or testing to prove the wind pressure performance. But it must be according to the national regulation of MSEN 1993-1-3, which refer to the EC's 3 standard. All right. So about the concentrated load performance, MS 2005 specified that MS 2523 or any testing method proposed by the manufacturer is acceptable. But both is required manufacturer to prove the performance through the testing. All right, so in short, no matter AS 1562 or MS 2005, both standards require manufacturer to prove the product performance in terms of the wind uplift capacity, Y, the wind pressure test, and foot traffic capacity through the concentrated load test. Okay. So as such, NS flow scope lights up product performance is proven by, we have two options here. If let's say option A, if the project is adopt AS 1562 and accepted by the consultant, our product is already tested with the AS 4040.1 and 4040.2. If option B is adopted, which is MS 2005 is adopted in the project, our existing test result based on AS 4040.1 should be recognized because the standard accept manufactured testing method. Regarding the wind pressure test, the test result according to AS 4040.2 should be deemed acceptable because MS EN 1993-1-3 has a lot of commonality to the AS 4040.2. So maybe a bit confused now. So talking about 4040.1, 4040.2, and how the test to prove the capacity of the product. So I will show you some detail in the subsequent slide, how we carry out the test. Okay, here is the flow of concentrated load test is carried out according to AS 4040.1, which is recommended by AS 1562. At first, we mount the cladding onto the point load rig and then we do the necessary setup. This is as shown here. Then we conduct the serviceability test and check the deflection. The residual deflection will be determined the cladding is pass or fail in the serviceability. So upon the serviceability test is completed, we move on to do the strength test. We apply the strength load onto the cladding, then observe the cladding behavior. If the cladding stay in the good condition, it is deemed pass. However, if there's any failure mode is observed, the strength is failed. All right. So once we completed the test, then we determine the maximum support spacing, then in the serviceability and also the strength, then we will publish it into our brochure. Okay, the concentrated load test according to AS 4040.1 can be conducted using the point load rig. So the photo as shown at the right hand side here is the point load rig. I think somebody maybe haven't muted the mic. Can you please mute the mic, please? Everyone, thank you. Okay, this point load rig is designed and fabricated by NS BlueScope to conduct the test according to AS 4040.1 requirement. We'll conduct the concentrated load test in two stages, as I mentioned earlier, which is serviceability and strength state. So how we conduct the test, I will show you in a subsequent slide. So this slide is show the step, how we conduct the test. We install the cladding onto the purlin, onto the point load rig. Then the concentrated load we apply to the cladding through the circular rubber pad. The black color here is a circular rubber pad. Before the test is started, the deflection gauge will be mounted beneath the cladding at the point load position. Then everything is set. Then we will apply the load gradually until we achieve 924 Newton, which is the serviceability load. Then we record the deflection. So maybe come to hear some of you will ask why we use 924, because 924 Newton is almost equivalent to 92.4 kg. This is like a man load that stand on the cladding. All right. So upon the deflection value is recorded, then we will release the load. Then we will see whether what's the residual with deflection.
Sorry.
Hi, can somebody please mute the mic? Thank you very much. All right, so let me continue. Upon the deflection load is released, then we'll wait for 3 to 4 minutes. Then we see whether the cladding can back to the original flatness. Then the guideline is a span over 1000. So which means, let's say it's 1.2 meter, we have to get back to at least 1.2 mm or less than that, then it's deemed that this serviceability is passed. Upon the serviceability test is completed, then repeat the same process, increase the load gradually until it's 2475 Newton, which is a strength load. Then we check the condition of the cladding, whether any tended, fastener pull off, or other any failure mode is observed. If everything remain in good condition, the cladding is considered passed in the concentrated load. Then we'll carry out the next test by increase the span until we come to the span that is filled. Then we'll take the span length before the failure is occurred as a maximum support spacing. I will show you some video later on. Right. Because this is the video to show you how we time lapse of how we conduct the concentrated load test based on serviceability. So this is how we apply the load 924 Newton. We wait for 1 to 2 minutes. Upon that, release that, then you can see that it's back to the flatness. So this is deemed that the test is past the serviceability. About the strength, repeat the same process, but we increase the load until 2645 Newton. Then similarly, we wait for 1 to 2 minutes, and then we release it. So in this condition, this profile is deemed is filled in this span length because the profile cannot back to the original flatness anymore. Okay, so now talk about the wind uplift test. Here is a flow of how wind uplift test is carried out according to AS 4040.2. At first, we mount the cladding onto the pressure rig and do the necessary setup. Do the necessary setup on the pressure rig. Then we'll put the deflection gauge, and then we conduct the serviceability test by apply the load until we achieve the calculated deflection, and then we record the serviceability load. The residual deflection will determine the cladding is passed or failed in serviceability. Upon the serviceability test is completed, we will move to do the strength test. We apply the strength load onto the cladding by increase the air pressure until the cladding is filled. After that, then we'll record the strength load. So once we completed the test, we harvest all the data, we apply the reduction factor according to AS 1562, then we'll publish the wind uplift capacity into our brochure. Okay, this is the pressure rig that I mentioned just now. This is the pressure rig that we designed and fabricated by NS Boost Group to conduct the test according to AS 4040.2 and operate by using airbag or direct air. Similarly to the concentrated load test, we'll conduct the wind uplift test in 2 stages, which is serviceability and strength stage. How we conduct the test, I will show you later on. Okay, we straight away go to this video. I will show you. All right, so this is time lapse. That you can see this, we have a 3 deflection gauge here. We'll measure the serviceability based on deflection. Then we will release the deflection gauge, and then we put in the air to the airbag or direct air until the profile is filled. The failure mode will be like, for example, unclipping of the profile, failure of the lapping, screw pull over, screw pull off, shear tear around the screw, buckling. This is all the mode that we determine whether the profile is filled. Upon that, then we'll record the strength. So maybe I play it one more time to show you because it'll be fastest now. So yeah, this is serviceability. Then remove the deflection gauge. Then we pump the air until it's filled. Then record the data. All right, so now we've done the comparison of the requirement appear in the AS 1562 and MS 2005. Now let's get into the requirement related to the meta sheet that only appear either in AS 1562 or MS 2005. So let's start with the design requirement according to AS 1562. And this section does not appear in MS 2005. So maybe this one will be a guideline for you if you adopt MS 2005 in your project. Okay, before I start to discuss this topic in detail, I just want to highlight that in this design section is elaborating the information that might be able to assist the designer to assess the product used in the project, whether achieve the basic standard. And it might be important for you to consider to put into your project specification so that the contractor can purchase and install the product that can meet the standard. Which means, for example, what I'm going to discuss later on, maybe the point that you maybe have to take note that you consider to put into your project specification so that whatever product that delivered to site is met the basic requirement. So according to the design requirement as specified in AS 1562, section 3.2, it breaks down into a few basic requirements that must comply when steel cladding is used in your project. Okay, we point it out. In the clause 3.2.2 about the imposed action, the standard specified that person may walk or stand anywhere on the roof without causing damage to the ship. So this condition shall be able to achieve by conduct the concentrated load test that I shared earlier. All right. Then refer to the clause 3.2.3, the wind action, the external pressure for cladding system of roof and wall without failure. So which means the code is specified that you must comply the imposed action and wind action that somebody walk on it and even the wind load is applying on it, the roofing sheet without failure. And these two shall be determined through the testing that I mentioned earlier. And in the clause of 3.2.5, this is very important that the standard stated that the cladding is not considered to be efficient restraint or supporting structure against buckling. So cladding should not be considered used as a structural design. So in other words, if you have a portal frame, you have a lateral root, you cannot use the roofing sheet as a restraint component. All right. Then about the clause 3.2.6, thermal movement, the standard stated that the system should be able to resist thermal loads or thermal movement. It is very important because the roof system design does not capture the thermal movement. The roof might be filled by local shear happen at the screw area, which is as shown in this small photo here. Eventually, it leads to the rainwater leakage at the screw area. So in other words, if you have the inlet area in the screw fix cladding, but it does not consider for the thermal movement, both steel will be moved in different direction. Then you will have a shear failure in the screw area. Or maybe you can call it bearing failure in the screw area. So you will create a bigger hole at a particular position, then will lead to the water leakage. Can refer to the section 3.3, roof drainage, table 3.1. Okay, this is indicated the minimum slope of roof requirement for different kind of the roof cladding. So this value is calculated according to the formula as stated in Appendix D of the AS 1562. The formula can be used to determine the rainwater drainage capacity based on a certain profile and slope of roof. I will share it to you in the subsequent slide. Here is the formula we use to calculate the rainwater drainage capacity. These are the two different formula, this one and this one. The difference is for the first one is used to calculate the rainwater capacity, drainage capacity for the corrugated profile. And other profile like a white pen profile, you can use this formula. All right. There's one important variant in the formula that need to be highlighted. This is what I highlighted here, the A prime. This is the cross-section area of the water in the roofing module, and it plays a very important part to determine the rainwater drainage capacity of the profile. All right, A prime, which is the cross-section of the water area, is calculated based on the trapezoidal area as highlighted in gray color as shown here. Okay, so the width of the trapezoidal, the width, which is the width here, is determined by the height of the water level, which is the dm. Okay, dm. The height of the water level allowed the standard to determine by whether there's an anti-capillary groove is provided. Okay. According to the code, if anti-capillary groove is provided, we are allowed to use 60 to 75% of the full rib height to determine the water level. So in reverse, if the profile do not have the anti-capillary groove, we are only allowed to use 75% of the height from the pen surface until the lapping area here. Can you imagine the difference? There will be a huge difference in terms of the cross-section water area can use in determine the rainwater drainage capacity. Therefore, anti-capillary groove is a small thing, but it is very important because designer have to increase the slope of roof if the profile do not have the anti-capillary groove. So we keep on talking about anti-capillary groove just for the audience that didn't aware what is anti-capillary groove. So the small section area here is the anti-capillary groove. So the function is just like when you have a small area, the water easily to seep in. But when the water seep in through the small area, encounter with the big area, subsequently, the water will stop to seep in through the inner area. So this is called anti-capillary groove. So just to show you some example for our products, like Kevlar Optima, we have this anti-capillary groove provided. Even as simple as Spandex Optima, we also provide anti-capillary groove. Okay, let's get into the installation part. And this section is only appear is NS 1562, MS 2005 does not specify the installation in the standard. Right, in this in this section, the talk about the installation is equally important as the design section that I shared earlier. So designers shall consider to specify those important information that I'm going to share with you into your specification so that the contractor is aware the basic standard shall be complied on site and deliver the quality work to the end user, which means whatever I'm going to share with you, maybe you can consider to put into your specification or maybe to your tender document to ensure contractor do it accordingly and end up the quality work is delivered. All right, so let's start it for the sharing. You can refer to the AS 1562, section 4.4, fastening. It spelled out that a few recommendations to guide user to do the right work in installation. So in the clause of 4.4.2, pierce fastener cladding, it stated that the washer shall be compressed to minimize the water leakage. So the washer is the black color here under the screw head. We call it as the rubber washer. Okay, so the clause is stated that you need to compress the rubber washer so that to minimize the water leakage. But let me add on to this clause is, although compress the rubber washer is very important, but the installation skill of the worker is very crucial too. Because if the screw is underdriven, this is what happen is underdriven. The rubber washer is not able to seal up the drilling hole and cause the water leakage. Okay, in reverse, if the screw is overdriven, this is overdriven condition, the rubber washer will be damaged and lead to the water leakage problem. So ideally this is the way to compress the rubber washer to seal up the water leakage. And this is really depends on the skill from the workers. All right, in the same clause, it's mentioned that we should prevent the entrapment of the swath between the seal and the cladding of fastener because it will accelerate the corrosion at the screw area. Eventually, the screw fix area might be filled due to the movement of the wind action. So the swath is this small debris here, and it happens is when the screw drill through the cladding, this is the debris that appear around the screw area. So you must clear it off before you close up the screw. It might be a major concern when corrugated product is used in the project because most of the corrugated product is fastener to the support solely by the screw fix. So we must pay extra caution and ensure the suggestion in the clause can be complied when corrugated product is used in the project. So this is the graphic as I show here in left-hand side, just to show you that most of the corrugated product is screw fix and this is direct screw in. So these two factors, you might be considered to highlight to your contractor that you must install it at least don't come to the condition is like underdriven, overdriven, or at least try to clean up the swath as much as possible. Okay, regarding the clause 4.4.3 about the concealed fastener cladding, the standard just give a very simple suggestion that the sheathing of the concealed fixed profile must be installed onto the clip system, but not screw fix it. So in other words is, let's say for example, like Clip Optima, we are using the clip to engage the sheathing to the support. So whatever cladding that's secure onto the support structurally, you must use the clip system. You cannot screw fix it. It doesn't mean that you cannot use any screw on the concealed fixed profile or the product. You still can use the screw for the flashing or maybe for the edge, but for structural engagement, you must use a clip. So this just show the symbol that you cannot use screw fix for the concealed fix for the structural engagement. Okay, in the clause of 4.5, cladding labs, it stated that the end lab requirement to help the reader to understand the limitation of the end lab length based on the different application and condition. So just to share is for some project, the cladding length is controlled by the deliverable or maybe for the logistic limitation. You cannot do it in full length. You will be having this end lap on site, which means you lap it piece by piece on site to form the full length on the roof. So we have some end lap on site, but what is the end lap length? For you to assess whether the contractor do it correctly or not, this is the thing that you can assist you accordingly. So at least in this table, there are the requirements suggested by AS1562 in terms of the end lap length. So this is the end lap length, the end lap in between two sheets. So it suggested that the roof less than 15 degrees, the end lap length should fall in between 200 to 300. If the slope of roof more than 15 degrees, the minimum lap length shall be 150, maximum is 250. And for wall, because there's no gradient, so it's very straightforward. It just suggested that the end lap shall be between 100 to 200. All right, this is suggested by AS1562. And there's some clause also helping you to determine the screw, the steel grade and the metallic coating for the flashing. So in this clause 4.8 flashing, 4.8.2 minimum thickness, the table 4.1, this table 4.1 is indicated the minimum metallic coating, base metal thickness, and steel grade of flashing and capping. So refer to the zinc coated steel, pre-painted or unpainted. The minimum metallic coating must be AZ 150. And base metal thickness shall be 0.55 for G300 or 0.42 for G550. So this is a minimum cap that you can use for the flashing material. As such, you should not use any flashing material with the lower than the spec if AS1562 is adopted in the project. Just to highlight to the audience is for those who don't understand what is flashing and capping. So this diagram is showing that whenever the flashing sheet to seal up the edge, we call it as flashing or capping. And refer to the clause 4.8.3, fastening, table 4.2, this table 4.2. The standard specified the maximum fastener spacing for flashing. So which means even the fastener position, there's a recommendation if you adopt AS1562 in your project. There are different guidelines for the transverse and longitudinal flashing. The difference in between these two orientations can refer to the graphic here. So what is transverse flashing is, we always refer for the roof. So if the roof is spanning in this way, and your flashing is spanning the other way, so we call it transverse flashing edge. In reverse, if your roof is spanning parallel to the flashing, we call it as longitudinal flashing edge. Right. So the maximum fastener spacing of transverse flashing is 310 mm, whereas the fastener spacing for longitudinal flashing should not be more than the support spacing, such as purlin, girth, and batten. So just to highlight that whatever I'm talking about now is mainly focused on the non-synchronic wind region. So if you have a synchronic region project, you must refer to this column. So in other words is for non-synchronic region, the suggestion from the code is the screw position for the transverse flashing should not be more than 310 mm, center to center. But for the longitudinal, it does not specify numerical figure into the code, but it just suggested that you must at least follow the support position, which is either the purlin, girth, or batten. Okay, here is the last topic of today, which is the shortest topic also. It's the specification according to MS 2005. This topic is only appear in MS 2005. But not appear in MS AS 1562. So it's worth to be highlighted, although it's short, it's worth to be highlighted and make it as a reference. Okay, refer to MS 2005, section 7, marking, labeling, and packing, clause 7.1.2, labeling. The standard suggested the manufacturer to attach the label to each bundle of delivery to help the goods receiver identify the product is according to the specification. I put the example in this table. In the normal practice of NS Bootstrap LISA, we provide the table according to MS 2005, which give the information such as the manufacturer's name, profile name, steel grade, metallic coating, product dimension, order number, quantity, and color we display in the bundle. So this is very important that roofing sheet, when delivered to each site, maybe have different requirement. So this is to help the goods receiver on site to ensure that whatever they receive is actually according to the design requirement or the specification. So that's it for my sharing session today. Please do not hesitate to contact us if you have any queries in the future, or explore to our website to find out more about our products. You may stay tuned to our social media to find out our next webinar. Feel free to ask any question if you would like to clarify anything that's not clear that I'm sharing just now. Right, thank you.